An important property of these quasi-cycles of eccentricity and inclination is that they only start to occur beyond the critical inclination angle. You see a situation in here where you have an orbit and then the distant perturber. What this diagram shows is that if the mutual inclination of the inner and outer orbits is below this critical angle, if it falls on this wedge, you don't have cycles. You only start having the quasi-cycles once the inclination is beyond this critical angle, once the inner and outer binary are significantly inclined with respect to each other. We can find the signature of this critical angle if we look at the irregular satellites of Jupiter and Saturn. These are plots of the known irregular satellites of the two gas giants. If you see the inclination of the irregular satellites of Jupiter and Saturn, it turns out that they never go much beyond 40 degrees. You see here, these are the irregular satellites of Jupiter, both the prograde and the retrograde. The prograde, there are a few of them that are beyond, but not much beyond 40 degrees. And for the retrograde ones, again, 40 degrees, so beyond 140, you do not see many irregular satellites. Same thing for Saturn, you have a cutoff in irregular satellites around 40, 50 degrees. And the same thing here for the retrograde, you don't see many beyond 140. What is going on is that beyond this critical angle, you start exciting these quasi-Lidov oscillations. And if you have these very high inclined systems, you start trading through these quasi-Lidov oscillations. You trade eccentricity for inclination, and you can eventually get to an orbit that is so eccentric that they collide with the planet, and then the satellite is lost. So let's see how we can derive this critical inclination angle.